let's do a little review here for chapter 4. So I'm on review sheet number 1, and the first problem says 3 secant angle whose cosecant is 8/5. All right, now we've got to remember, it says first of all with calculator. All right, so let's do it with our calculator. Now, before I put this in my calculator, I'm going to rewrite it because, quite honestly, kids, I don't have either one of these buttons. So I wonder, what am I going to press? Well, I'm going to press 3 times something. I'm going to press, I need a secant, and I know that a secant is 1 over the cosine. This is an angle. This is the angle whose cosecant is 8/5. Well, that's the same as the angle whose sine is 5/8. So I'm going to type 1 divided by cosine, because that's what secant is. And then the angle whose cosecant is 8/5 is the angle whose sine is 5/8. So that's what I'm typing into my calculator. Actually typing 3 times 1 divided by cosine, second sine, 5 divided by 8. Now, I don't have to put in any parentheses until the end. Well, I guess I got to press equals. And my answer comes out to be 3.8431. Right there you go. Now, I'm going to hang on to that because now I'm going to do it without a calculator. And then I'm going to kind of compare and see if my answers match, which hopefully they will. All right, so here we go. I remember that anytime I'm finding an angle whose something, sine, cosine, tangent is, when I use this notation, if this is a positive number, I'm in quadrant 1. Remember, if that's a negative number, there are rules you have to follow. Go back and study that video if you've forgotten those rules. Now, I know that I'm in quadrant 1 because that number is positive. I know that the cosecant is 8/5 or the sine is 5/8. I know that that will be 64 minus 25, root 39. And that takes care of this. So far, all I've done is draw a picture of that angle. I don't know what that angle is. Doesn't matter. I want its secant. And its secant is hypotenuse over adjacent, which is 8 over root 39, or 8 root 39 over 39. So I'm just going to, for fun, type 8 divided by the square root of 39. And it is not the same. Oh, because I forgot to times it by 3. Times it by 3. There we go. Now it is the same. I forgot that 3 there. So this would actually be 24 root 39 over 39. Because there's a 3. So I got to find this and then times it by 3. Oh, I guess that reduces, doesn't it? So that would be 8 root 39 over 13. That would be my final answer because 24 over 39 reduces. Okay, good deal. Now we're going to do a sketch. Now, this problem is written differently than we normally write it. But I noticed that your book does this, and I wasn't sure if you've been used to seeing them like this. So we'll have one like this, then we'll talk about what this means if you don't know. First of all, let's move this 2 to the end. That's where we normally see it. That's where we normally see our vertical shifts, at the end. So that's a plus 2, that's a positive 2. I'm going to tack it on the end. This, of course, is a negative 4, so it's going to stay there. Now, there's one more thing about this problem that I need to take care of right away, and that is this. we need to get that out of the parentheses. Because if we don't get it out of the parentheses, it's going to mess up our phase shift. So we're going to pull that 5 out. And when I factor out a 5, that's division. Factoring is division. When you factor something out, you divide it out. So I'm going to divide by 5, so this is going to be pi over 10. Now, before you say, oh my gosh, how did you get it? Calm down. If I distribute it back, do I get pi over 2? I do. So your job is to figure out what goes here so that when you times it back together, you get what you started with. Factoring is division. Pi over 2 divided by 5 is pi over 2 times 1/5. That's the math. But just so, however you get it is up to you, but make sure that when you multiply it back, you get what you needed. Now I'm ready to sketch. So I'm kind of out of room here, so I'm going to erase this. Here's my equation now after I've gotten it all like I want it. All right, so now we're going to sketch it. So we have an amplitude of 4. So there's 4 and -4. And I'm going to go ahead and sketch this, and then I'll move it up 2. But I'm going to sketch this first. Now, some of you that can keep track of a lot of things, maybe you can do it all together. I can't. I have to go ahead and sketch the regular curve and then move it up 2. So I know this is a sine, and it's a sine, or at least it starts as a sine, and it has a phase shift of pi over 10. So I'm going to have a sine curve with a phase shift of pi over 10. Now, what's my period? So there's my sine curve. Oh shoot, it's negative, isn't it? Gotta take care of that, gotta pay attention. There we go, it's a negative sine curve. So we got it upside down now. Now what's my period? Well, my period is supposed to be 2 pi, but this time it's been divided by 5. So my period is 2 pi over 5, which is the same as 4 pi over 10. So I can figure what this is by starting at 1/10 and adding 4/10. So this is going to be 5 pi over 10. Now I know that reduces. You can reduce it if you want, but you don't have to, because now we're going to find these other points, and we're going to do that by averaging. So 1/10 and 5/10 is 6/10, divided by 2 is 3/10. 1 and 3 divided by 2 is 2, and 3 and 5 is 4. Now again, no one's going to mark you off if you do not reduce these. When you're doing all that arithmetic, it's easier to keep the common denominators. Okay, so that's this, except I need it to be a cosecant. So I know I drop in my asymptotes wherever I cross an axis. So here, and here, and here. And I'm going to flip the curve. And I'm lazy. These were supposed to have arrows on the ends. There you go. Now I've got this dashed blue, which is literally a picture of this. Now I need to take it and move it up 2. So now I'm going to take this dashed blue parabola, and I'm going to move it up 2, and this one's going up 2 also. And there you go. The purple, and I know that's quite a cluttered mess, but the purple is actually the answer to the question. Okay, good deal. All right, number 3. Now we are solving an equation. And we're doing it in radians. You can tell from the domain that's given. You're doing it in radians. So tangent equals 4/3. Now, obviously I'm going to need a calculator. 3 and 4 are not my special numbers in terms of, 30s, 45s, and 60s and all that. However, before I do that, before I go to the calculator, I want to stop and figure out where these angles are going to be. That's a positive tangent. Keep in mind your domain is all the way around the circle. We're going all the way around, one full revolution, and we need the tangent to be positive. Well, where is the tangent positive? Well, it's positive in quadrant 1 because everything's positive in quadrant 1. And it's also positive in quadrant 3 because in quadrant 3, the x and the y, the adjacent and the opposite, are both negative. So when you make your tangent fraction, y over x, opposite over adjacent, it comes out positive. So now I'm going to go to my calculator. I'm going to set myself in radian mode. Again, we're in radians. And I'm going to type second tangent 4/3. 0.93. So the answers to the question are these two angles. This one right here, the black one, the black angle, and the purple angle. Those are the answers to the question. So the black one is 0.93. And the purple one, remember you're in standard position, not Y. The purple one is all the way around to here. So it's going to be pi plus 0.93 or 4.07. So that's pi plus 0.93 because you're going half a revolution and the additional 0.93. All right, that's not too bad. What do we got next? Okay. Now we're going to find some area, it looks like. The area of a sector. So remember that this piece of pie here, this thing, is called a sector. And for part A, we are told that this is 150 degrees and the radius is 6. There's always more than one way to do this problem. I am not sure how you like to do it. I always fall back on my geometry. I know that this piece of pie is a piece of the whole pie. And I know that the area of the whole pie, the area of the whole, you'll see what I'm doing here in a minute if you haven't figured it out. The area of the whole is pi r squared, so it's 36 pi. The area of the circle is pi r squared, 36 pi. I want to know what the little area is. That's my job, so I'll call that x. I don't know what the little area is. Now I know that the whole angle, that is the entire revolution, is 360. And I know my small angle is 150. So I'm setting up a proportion that says the piece over the whole equals the piece over the whole. So 150 is the little angle. 360 is the whole angle. So 150 is to 360 as x is to the whole area. So x equals 36 pi times 150 divided by 360. This is the way you did it in geometry, whether you remember that or not. This is indeed what you did in geometry. Let's see, we can do some canceling here. Those are going to cancel. These are going to cancel. And it looks like the answer is 15 pi. So the area is 15 pi. Now we've got the same circle. But this time, we know the angle is 1.2, and the area of the circle is 10. And we're going to find the arc length. Well, there are a couple of strategies we can use, but to kind of reinforce this idea, we could say 1.2 is to 2 pi. Now, again, that's a radian measure, so I'm putting it over 2 pi. This was a degree measure, so I put it over 360. So the little angle is to the whole angle, as the little area is to the whole. Oh, wait a minute. Wait a minute. The area is 10. Pi r squared equals 10. So can't I find my radius, guys? Can I find my radius? So it looks like the radius is the square root of 10 over pi. It said the area of the circle is 10. So pi r squared is 10. So r is the square root of 10 over pi. That's not a very pretty number, but it's what we've got. Now we want arc length. And we learned in this chapter, way back at the beginning of the chapter, that arc length equals the radian measure of the angle times the radius. Now you may have learned that as theta r or something like that, but it's the same thing. It's the radian measure of the angle times the radius. So I know that the radian measure of the angle is 1.2, and I know that the radius is the square root of 10 over pi. That is the arc length. What a mess, but that's it. That's the answer. Don't worry about trying to rationalize that. Pi is already irrational, so it doesn't make any difference. We'll just leave it like that. All right, that was an interesting problem. Okay, number 5. Now we're going to find the exact value. So this means no calculator. We're going to find the exact value of the cotangent of 8 pi over 3. Now again, the beautiful thing about math is there's always more than one way to do it. When I look at 8 pi over 3, I immediately think that's more than a revolution. Remember, a revolution is 2 pi, and so that would be 6/3. So 6 pi over 3 is a revolution. So I really don't care about the extra revolution. So the cotangent of 8 pi over 3 is going to be the same as the cotangent of 2 pi over 3, because that extra revolution comes out. Think of it the same way you would think of it if you had 400 degrees. Well, 400 degrees goes all the way around and then some, right? All you really care about is the then some, because that's what determines where you are. So I got rid of that extra revolution. Two pi over 3. Pi is 180, so this is going to be 120 degrees. Pi over 3 is 60, 2 of them is 120. So I'm going to draw 120 degrees in standard positions. It's going to look like this. I'm going to drop that perpendicular straight down. Now, if that's 120, and this is 60. And again, if you have other strategies to do the problem, that's super okay, as long as we get the same answer. So if that's a 60, then I know this is a root 3, this is a 1, this is a 2, and that has to be negative because I'm in quadrant 2, negative x. Cotangent is adjacent over opposite, so that'll be negative 1 over root 3 or negative root 3 over 3. So if you have another means, if you're using your unit circle, for example, you should get exactly that same answer, negative 1 over root 3 for the cotangent of 120. All right, next we've got the sine of 180. Now, 180 is what we call a quadrantal angle. 180 is actually on your unit circle. It's not like jutting out like 120 was. It's actually on the circle. So that point on the circle is negative 1, 0. This is a unit circle. Its radius is 1. The x value is negative 1 and the y value is 0. For 180 degrees in the unit circle, the point is negative 1, 0. We want the sine. Sine is y over r, so my answer is 0 over 1 or 0. Now we have cosine, negative 10 pi over 3. Now don't freak out about the negative, that just means we're going this way. We'll go this way around our unit circle. The 10/3 is more than a revolution. So I'll do the same thing I did last time. I'll pull out the extra, and it's negative 4 pi over 3. Because 6/3 is a revolution, 2 pi. This will be the same as, let's see, 180, that's negative 240. Pi is 180, divided by 3 is 60, times 4, 240. So we'll draw 240 degrees negative. That means I'm going this way. Oh, I think I'm going to get the same triangle I had a minute ago. Because if this is negative 240, and I know this is 180, isn't this going to be 60? It's going to be 60. So if that's a 60, then this will be a root 3, this will be a 1 and a 2, and that's negative again. Same triangle I had up here a minute ago. I want cosine adjacent over hypotenuse, negative 1/2. Negative 1/2. Okay. Write the equation of the cosine curve with amplitude 1/2. So we're going to write the equation of a cosine curve, and the amplitude's 1/2. And the phase shift is negative pi over 16. So I know in my parentheses I'll have x plus pi over 16. And now I need to figure out this number. Now that number influences the period. I know that 2 pi divided by that number gives me my period, which in this problem is 8 pi over 7. Remember, 2 pi divided by this number, I'll call it n for the time being. You may call it b, sometimes we call it b, whatever you call it. So 2 pi divided by that number is going to give me my period. So I'll just figure out what that is. So 14 pi equals 8 pi n. Now the pi's are going to cancel. So n is going to be 14 over 8, 7 over 4. There you go. Perfect. Number 7. what is the oh, by the way, there's more than one answer to this problem, but that would be the most obvious one. What is the frequency of this equation? Now, what I don't know is if you guys talked about frequency. I went ahead and factored out my 110. Although for this problem, I wouldn't have to. I'm not graphing it. But for practice, I went ahead and factored out my 1/10. Factoring out 1/10 is like dividing by 1/10, which is multiplying by 10. So that's how that got there. And again, distribute it back, and you get your pi over 2. But again, that has nothing to do with the frequency. Frequency is the reciprocal of the period. Okay? So I'm going to find my period, because I know how to do that. My period is 2 pi divided by, in this case, 1/10. So my period is 20 pi, meaning my frequency is 1 over 20 pi. And when I write that, I'm really careful to make sure it's clear that 20 pi is in the denominator. Now, if you guys already understand what frequency is, go ahead and fast forward, because I'm going to do a quick explanation of frequency so that you understand what I'm talking about. I'm going to draw, those numbers are a little complicated, so I'm just going to draw a couple of little sine curves. And we'll leave the pi's out just so we don't have any complications at all. All right. All right, so I've drawn a couple of little sine curves here. You can look at this one and tell me that the period is 4. That's how long it takes to get a cycle completed. You can look at this one and tell me that the period is 1/2. 4/8. That's how long it takes to get a cycle completed. Now, frequency is the number of cycles or the number of periods in 1 unit of length. So if we look up here at this top one, this is a unit of length, 1 unit of length, right here, 1. That's it. Frequency is how many periods I did in that space. Well, I didn't even do a whole period. I did 1/4 of a period. There's a 4th, there's a 4th, there's a 4th, there's a 4th. So my frequency is 1/4 because I only got 1/4 of a period done. Now in this one, 1 unit of length is here. This is 1 right here. Well, how many periods did I get done? Well, there's 1. And there's another 1. So my frequency is 2. See the relationship there? They're reciprocals of each other. Frequency is the number of periods you get done in 1 unit of length. Okay, so now you know what frequency is if you didn't before. Now we're going to do another sketch. All right, so here we go. This is question number 8. We are sketching y equals 1/3 sine. Now, I'm going to go ahead and pull out that -2 and x minus pi over 12. I'm pulling out a negative, so this is going to become negative. I'm dividing out a 2, so I'm multiplying by 1/2. If I times these together, I get positive 1/6, which is what I had. Now, here's another thing that I don't know if you know or not. When you have negatives buried inside the problem, you know those are reflections across the y-axis. You learned that earlier in the year. Instead of trying to reflect one of these freakish things across the axis, what we normally do is just understand that for all of the functions that have no symmetry about the y-axis, what we do with that negative is we simply pull it out front. So if your function is anything except cosine and secant, you're going to pull it out front. Cosine and secant are what we call even functions. They have symmetry about the y-axis. So if your function has symmetry about the y-axis, then this negative is meaningless. So if we had, 3 cosine negative 2x, okay, we would simply erase that negative. With a cosine and a secant, that negative just disappears because the function is even. It has symmetry about the y-axis. Remember, cosine looks like this, so it's symmetric about the y-axis. And of course, its reciprocal is. So the cosine and the secant are the only 2 even trigonometric functions. So if you have any other function besides cosine and secant, if there's a negative inside, you pull it out in front. Because a negative inside is going to make your function negative, or the opposite. This, if you have a negative in a cosine or a secant buried inside, I'm not talking about out in front, I'm talking about buried inside. If you have a negative buried inside of a cosine or a secant, you simply erase it, disregard it. So one more time, if you have 6 trigonometric functions. If you have an equation that you're graphing, and there's a negative inside here, that negative is going to come out in front, effectively flipping your picture over, unless the function is a cosine or a secant. If it's a cosine or a secant, that negative means nothing and you can just erase it. Otherwise, bring it out in front. Okay, so I brought it out in front. Now I'm ready to go. I don't know why I just put that over so far. All right, so here we go. I have a phase shift of pi over 12, and I have an amplitude of 1/3. It's a negative sign, so I'm going to go ahead and sketch in my negative sign. My period for a sine is supposed to be 2 pi, but it's been divided by 2. So my period is pi, which is 12 twelfths. 1 pi, 12 twelfths. So I'm going to end at 13 twelfths. Remember, to find your ending point, you just take your starting point and add your period. My period's 1, or 12 twelfths. 1 and 13 makes 14, half of that's 7. 1 and 7 makes 8, half of that's 4. 7 and 13 makes 20, half of that's 10. And my friends, I think we're done with that one. Okay. I guess we're ready for number 9, which says find the exact value. And I've tried to get wild and wacky with you, but you're not falling for it. Negative 20, 21 pi, that's a huge angle. It's a huge angle. Clearly more than one revolution, isn't it? Remember that a revolution is 2 pi. So every even pi, 2 pi, 4 pi, 6 pi, blah, 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 every even pi is just a spin. So I'm not going to consider this monstrosity. I am going to boil it down to negative pi. Because if I take out the even pi's, that would be 2020. 2020 pi would come out. That's 1,010 revolutions. That just comes out. And I'm left with negative pi. Every even pi is a revolution. I don't want to sit there and graph this thing because it would just be spin, 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 spin 1,000 times. Plus, more than 1,000 times. I don't want to do that. So instead, I pull out all the even pi's, and that leaves me with just my negative 1 left over. So I know that negative pi is right here on my unit circle. I know that x is negative 1, y is 0, and r is 1. I'm in the unit circle, so my radius is 1. This is negative pi. It also happens to be positive pi. Tangent is y over x. So the answer to the problem is 0. All right, I have a wheel with a 10-inch radius turning at 1,500 RPMs, revolutions per minute. How far will it travel in 8 hours? Okay, this is like those problems you do in chemistry. We're turning at 1,500 revolutions per minute, so let's start with that. 1,500 revolutions per minute. Okay? It has a 10-inch radius. All right, now just wait a second. It has a 10-inch radius. So 1 revolution is a circumference. Okay? Think about this for a second. You got a wheel, put a blob of white paint on it, and roll, just put one blob of white paint on it and roll it down your black driveway. Every time it goes around, it's going to leave a blob. It's going to leave a white mark on your driveway. And those white marks are going to be 1 circumference apart. So every revolution covers 1 circumference of distance. And if the radius is 10 inches, a circumference is 20 pi inches. A circumference is a revolution, and in this problem, a circumference is 20 pi inches. Okay, now, I need 8 hours. Well, I've got minutes here, so let's say 60 minutes is 1 hour. Would you agree with that? So if I multiply, let's see, my revolutions are gone. Right now, I know that I'm going that many inches in an hour. I have left inches in an hour. Well, that's going to be a lot of inches. So let's change that to feet. Let's say 1 foot, 12 inches. And then let's say 1 mile is 5,280 feet. Okay? So now if you look and see what we've got here, we got rid of the inches, we got rid of the feet, and now it looks like all I have left is miles per hour. So let's figure out how many miles an hour this thing is going. So we'll take 1,500 times 20 pi times 60. I think that's all my numbers on the top. 1,500 times 20 pi times 60. And now I'm going to divide that by 12. And I'm also going to divide that by 5,280. So this thing is going 89.25 miles per hour. Be careful, by the way, when you do this division. If you were listening, you heard me say divide by 12, divide by 5,280. If you take your numerator and hit divided by 12 times 5,280, it will not divide by both. You can either put it in parentheses, that will work. So your numerator divided by parentheses, 12 times 5,280, or you will need to do divided by twice. Divided by 12, divided by 5,280. Anyhow, this thing's going 89 miles per hour. But I wanted to know how far it will go in 8 hours. So I'll need to multiply this by 8. And the answer is he's going to go about 714 miles. It came out to be 713.998. So I'm going to go ahead and make that just 714 miles. All right, next problem says I know the secant is -4, and I know that I am in quadrant 3 or 4. That's what this means. Remember, standard position, this is 180, this is 360, so I'm in quadrant 3 or 4. And the secant is -4. Wait a second. Secant is reciprocal of cosine. So the cosine has to be -1/4. That doesn't happen over here. It can happen over here. So even though my domain includes both of these, that's not an option because the secant isn't negative in quadrant 4. The cosine isn't negative in quadrant 4. Cosine is x. X over r. Sine is y over r. So the sine, the SIGN of the cosine depends on what the sine of x is, the SIGN of x. All right, so I'm in quadrant 3. I know this side has to be the square root of 15 negative because the Pythagorean Theorem says 16 minus 1. And I'm supposed to be finding the tangent. So the tangent of this angle is root 15. It's negative root 15 over -1, so it's just root 15. Okay. All right, here we go. I'm supposed to write 2 equations. Because here's the deal, folks. This looks just like a cotangent to me, so I'm going to think of it as a cotangent. But it could also be a negative tangent. That shape can also be a negative tangent. Okay, so here we go. I really got more than I need here. This would be a period. So a period appears to be 4 pi over 6 or 2 pi over 3. So it looks like 1 period is 2 pi over 3 for this particular function. It also looks like we have a phase shift if this is a cotangent, remember that your normal cotangent has an asymptote at the origin. So that asymptote has been shifted over pi over 6. In a cotangent, the origin is an asymptote. And when we talk phase shift, we talk about moving the origin. We're moving the origin. We're moving 0. So my phase shift is pi over 6 for the cotangent. Now, the normal period of the cotangent is pi. This one is 2 pi over 3. So there's a number here that when I divide pi by it, because pi is the normal period, when I divide pi by it, I get 2 pi over 3. The normal period of the cotangent is pi. Obviously, it's been changed, so pi divided by something gives me my period, which is 2 pi over 3. So solving this, it looks like n equals 3/2. So there is a picture, or excuse me, an equation for my cotangent. Now, you have to be careful if you're thinking about this as a tangent, because in a tangent, remember, the origin is the intercept, is the dot. So if this is a tangent, this is our phase shift. Because when we phase shift, we move the origin. So the dot is getting moved. So let's see, it looks like that dot would be at 1 and 5, that's 6. So 3/6. I'm going to think of that as pi over 2 since I'm writing it in an equation. So my phase shift is pi over 2. Now, is the coefficient here still 3/2? Absolutely. That hasn't changed. The distance between the asymptotes hasn't changed. Just your starting point changed. Instead of starting with an asymptote, we start with a dot when we do the tangent. And it's negative, of course, because a tangent is supposed to be going up, not down. So those are your two equations. All right, 13, an angle in standard position. In which quadrant is it? So you're going to draw an angle in standard position. Where are you going to draw it so that the cotangent is negative and the sine is also negative? Now, don't get confused. Sine is y. Sine is associated with y. If y is negative, then you have to be here or here. This is where the sine is negative, because sine is y. Now, in this quadrant, maybe I'll write it that way. I'll say y is negative. Okay? Now, if y is negative, down here, let's talk about what x is. X would also be negative here, and x would be positive here. Now, we need the cotangent to be negative. If we build the cotangent, it's x over y. Will that be negative here? No, that'll be positive. Will x over y be negative here? Yes. So the answer to the question is quadrant 4. The whole positive negative thing is so easy, you guys. If you just remember, cosine is x, sine is y, and tangent is a combination of both y over x. 14, I do not know if we ever talked about this. I know I didn't talk about it with you. I don't know if you ever talked about it. So let's talk about this real quick. Not a huge deal. Very, very easy. Okay, so here's what I want you to do. You've got some big function that's a combination of these two. We could type it in our calculator and graph it. We're not going to do that. We're going to answer one question. What's the period of this thing? It is a periodic function. When you add a couple of periodic functions, you generally get another periodic function. So we want to find out what is the period of this whole thing. Well, to answer that question, we're going to find the period of each piece. What's the period of this piece? Well, it would be 2 pi over 2, which is pi. What's the period of this piece? Well, it would be 2 pi over 3, which is 2 pi over 3. Now, here's what I want you to think about what that means. If you drew just the first piece, every pi, so here's 0, every pi it would repeat. So it repeats at pi, and 2 pi, and 3 pi, and 4 pi, and so on. This one starts at 0. Every 2 pi over 3 it repeats. So it repeats at 2 pi over 3, 4 pi over 3, 6 pi over 3, 8 pi over 3, 10 pi over 3, and so on. The first time they both start over again is the period of the composite. So, take a look at this. See this right here? That's the same as 2 pi. So what that means is they're both starting over at 2 pi. So their period is 2 pi. They go 2 pi, and then they both start over. So the answer to this question is 2 pi. The period of these two added together will be 2 pi. Notice they start over again at 4 pi. Of course they do, because their period is 2 pi. So every 2 pi, they are both starting over. All right, let's do the next one. By the way, if the two functions that you happen to be adding together have the same period, these do not, but if this one was pi and this one was pi, then of course their period of the sum would be pi, but they're called sinusoidal. They're called sinusoids if they have the same period. All right, so let's see this one. Takes forever just to write it. Okay, so we find the period of each piece. Now, if I were graphing this, I would want to pull that 3 out. But I'm not going to take the time to do that. This video is getting long enough as it is. I am just going to find the period. So if I pulled it out, it'd be a 3. So my period here is 2 pi over 3. This is a secant. The normal period is 2 pi divided by 3. Now, this is a tangent. So its normal period is pi divided by a half. So its period is 2 pi. All right? Now, again, what this means is every 2, they both start at 0, and then every 2 pi over 3, this one repeats. This is where it starts over again. So like if you were drawing a sine curve, there's 1, then it starts over, then it starts over, and so on and so on and so on. This one is 2 pi, so it starts at 0, starts over at 2 pi, 4 pi, 6 pi, and so on. Now again, the first place they both start over is the period of the difference in this case. So that would be 2 pi again. So the answer to this question is again 2 pi. I promise it's not always 2 pi. I randomly made these problems up, and it just happens they're both 2 pi. Kind of makes sense. I mean, 2 pi is kind of a special number. All right, so now we go to number 15. We are going to change $160 into radians. So pi is to 180 as something is to 160. That's how I do it. You may just multiply by something, and that's fine. However you do it, you want to end up with 160 pi over 180, so our final answer would be 8 pi over 9. So as long as you're ending up with 8 pi over 9, how you do it's irrelevant. This is the way I do it. You do not have to do it my way. You can multiply by pi over 180. If that's how you do it, that's fine. I'm not a very good memorizer, so I always kind of approach things from a logical standpoint. All right, now we got 3 radians, and we're going to answer it 3 different ways. So first let's do C, which is the exact degree value, and I'm going to do it like I do it, you do it like you do it, and I'm going to say pi is to 180 as 3 is to x. So pi x equals 540, and x equals 540 over pi degrees. So there it is. There is the exact degree measure. You may be multiplied by 180 over pi. Now, if I want the decimal value of that, I'll just type that into my calculator. 540 divided by pi is 171.89, roughly. I'm going to leave that on my calculator. I'll write it down there to fill in the blank, but I'm going to leave this on my calculator. Now, I'm going to go to second angle. And I'm going to go down to number 4, DMS. And it's 171 degrees, 53 minutes, and 14.419 seconds. So second angle, and then choose DMS for degrees, minutes, seconds. Have another equation now. Sine x equals negative 1/3. The last one we did one of these earlier, but we were looking at the whole revolution, I think, that time. This time we're looking only in the bottom half because it says between pi and 2 pi. So that would be down here. And our job is to figure out what x is. So I'm going to actually, x could be in either place because sine is negative in both places. So I'm going to get 2 answers. I'm going to find that reference angle first. So second sine 1/3. Remember, I have a thing about those negatives. I never type them in because I know my reference angle. This is 0.34. If you type in the negative, you're going to get negative 0.34. All that does is tell you that's 0.34. Negative 0.34 cannot be an answer to the question because we are between 180 and 360, or between pi and 2 pi. No negative numbers in there. So we're going to take pi plus 0.34 and 2 pi minus 0.34. So this one I think is obvious, pi plus 0.34, so I'll figure out what that is. And this other one, this purple one, if I went all the way around, it would be 2 pi, but I didn't go all the way around. I skipped this part. So it's 2 pi less 0.34. So the first one is 3.48. And the second one is 5.94. Okay? All right, I'm solving for x now. Again, I think I just did that. Now I'm solving for x again. Oh, without a calculator. Okay. So 2 cosine x equals 1, and cosine x equals 1/2, and I am between 90 and 360. So I'm in degrees. I'm between 90 and 360. I'm just randomly making up quadrants so you get some practice here. So 90 to 360 would be everything except quadrant 1. And the cosine is a positive 1/2. Kids, can't be over here. If the cosine is a positive number, cosine's x. The only option's right here. Technically, you got all 3 options, but not for this problem, right here. So the cosine is 1/2. Makes that a 60-degree angle. Please do not say negative 60. This is your domain. You're not going to be able to say negative 60. You're going to have to say positive 300. Okay. One more, and then we'll do a couple word problems and we'll be done. So here we go. Find all the missing parts of triangle CHS. So we got a 6 here, a 58 here, an X, a Z, and a Y, and we got to find all those things. Well, Z's a no-brainer. These two are complementary, right? Or all 3 of these add up to 180, so however you think about it, this is going to be, what, 31 degrees? 32 degrees. Been a long day, guys. 32 degrees. Okay. So now, I don't care. It doesn't matter which one we find first. Let's find x first. If we find x first, I can say tan 58 equals x over 6. Or I could say tan 32 equals 6 over x. Whichever flips your switch, it makes no difference. The answer is going to be the same. So if I do the top one, I'll just type, oh, am I in degrees? Ooh, make sure your calculator's set in degrees, folks. Hope I didn't need degrees earlier. Make sure you're in degrees. I am now. So I'm going to type 6 tan 58. And I got, for x, I got 9.60. Now, please don't do the Pythagorean Theorem because you would have to use your rounded off number. Use some trigonometry to find your hypotenuse. And again, doesn't make any difference which way you do it. If I could say cosine 32 equals, oh no, I don't want to say cosine 32. Maybe I say cosine 58 equals 6 over y. Or I could say sine 32 equals 6 over y. Either one of those is going to give you the right answer. Okay? So if I do the top one, y cosine 58 equals 6. So cosine 50, I said long day. So y equals 6 over cosine 58. So 6 divided by cosine 58 And for y, I got 11.32. Try it. If you did 6 divided by sine 32, you're going to get exactly the same answer. It doesn't matter which angle you use, just make sure that you have it set up correctly, you know, in terms of the fraction, adjacent over hypotenuse or opposite over hypotenuse or whatever. A quick check if you want to. If you square 9.6 and you square 6, and then you take the square root of that, you should get this. Now, it may be slightly off because of the round off, but it should be really close. All right, we have 4 word problems to do. Here we go. Jim looks at the top of a building and finds the angle of elevation to be 35. So we know what that means. Here's the building. Here's Jim. This is 35. He moves 100 feet closer, so this is 100. Now when he looks up to the same thing, his angle is 40. What is the height of the building? This is a little bit complicated. In chapter 5, we're going to learn how to do this a lot easier, but right now, we're going to set up a system of equations. Here's what I mean. That's what I want. I'm going to go ahead and call this right here y. Okay, y. And I'm going to write an equation that says the tangent of 40 equals x over y, which means that x equals y tan 40. Now, that's not a solvable equation. It has 2 variables in it. But that's okay, because I'm going to write another equation. That equation goes with this right triangle. Now I'm going to write an equation that goes with the whole right triangle, the whole shebang. So that's going to be tan 35 equals x over 100 plus y. See what I'm doing? So that x equals 100 tan 35 plus y tan 35. So I'm multiplying both sides by this, and that's a quantity, so I do a distributive, 100 tan, y tan. So I wrote a tangent equation, opposite over adjacent, for my 40-degree right triangle, and then I wrote the same equation for my 35-degree right triangle. Now notice, this is x and that's x. So now I'm going to say, I'm going to set them equal. Y tan 40 equals 100 tan 35 plus y tan 35. So I took my picture and I wrote 2 separate equations using x and y. And now I just did substitution. They're both equal to x, so they must be equal to each other. And now I got to solve this. And I know what you're tempted to do, and I know you could do it in a heartbeat if you typed in and got decimals here, but that's going to give you significant round-off error. So I want you to try to do this in terms of the variables and the tangents. Let's not go to our calculator just yet. Let's put all the y's on the same side. So y tan 40 minus y tan 35 equals 100 tan 35. So I just move this y over to this side. Now let's pull out the y's. So factor out the y's. So y times tan 40 minus tan 35 equals 100 tan 35. Now remember, we're solving for y, in this equation anyway. So I'm going to divide by this parentheses. So I'm going to have y equal to 100 tan 35 over tan 40 minus tan 35. Now I can type that in on my calculator. Make sure this is in parentheses. So 100 tan 35 equals, divided by parentheses, tan 40 minus tan 35. Oh, shoot. You got to be careful, guys. Divided by tan 40, parentheses, tan 40. And then on my calculator, parentheses come up automatically. So I have to close that parentheses. And then minus tan 35. And I got 504. So y is 504. Keep that number. We don't even need to write it down. Y is 504. So x is what I really wanted to know, though. So x, remember, is y times tan 40 from our first equation. X is y times tan 40. So y is on my calculator, so I'll just take it times tan 40. And the height of the building is 423.02 feet. Okay? I'm just doing a quick check here of something. Yeah. Okay, good deal. A lot of work there. A lot of work. Not hard at all, but a lot of work. And you do have to remember this thing about closing these parentheses. All right. Now we got an eagle on the top of a tree. And he's looking at a mouse on the ground. So here's my eagle on the top of the tree. The tree is 32 feet tall. Here's the mouse. And the mouse is 913 feet from the base of the tree. So we got to read our problem carefully. Our job is to find the angle of depression, which is for the eagle, which is the same as the angle of elevation for the mouse. So that's the angle I want. So tan x equals 32 over 913. So I'll second tangent 32 over 913. And oh, that's a tiny little angle because they're a long way apart. That's 2 degrees. So the angle of depression for the eagle and the angle of elevation for the mouse is 2 degrees. All right, now I have an 8-foot piece of wood propping up a fence. So here's the fence and here's the wood, kind of hold like a brace, kind of holding it up there. The wood makes a 35-degree angle with the ground. How high, oh, it's an 8-foot piece of wood. How high above the ground is the point where the wood meets the fence? So that's X. Here's the ground. Here's where the wood plank meets the fence right here. So we know what that is right there. Oh man, compared to what we just did with that Jim walking toward the building thing, this is easy. Sine 35 equals X over 8. So 8 sine 35 is the answer to the question. Whew, we could do a whole bunch of those. 8 sine 35, 4.59 feet. All right, one more. Make sure this video is still running. This is getting very long. Sorry, guys. Got a lot to review in this chapter. Okay, last problem. airplane, leaves an airport. Okay, now wait. You must remember, when we're doing directions, we're using the compass. And when we use the compass, the labels are different than standard position. So when you have a directional heading, my planes on this course, my ships on this course, this is the setup. All right, so here we go. Here's the airport. Right here's the airport. And the ship, or excuse me, the airplane, leaving the airport, it would be an airplane, on a course of 320 degrees. So 320 would be right here. Okay, this is 320 degrees, which I'm going to kind of keep track of that. Let's see, if this is 270 and that's 320, wouldn't this be 50 right here? I'm going to make that 50, and I'll make this 40 just to remind myself. So 320 degrees is up here in this quadrant, and that part would be 50, 270 plus 50, and that would be 40, 360 minus 320. Okay? Okay. All right. What does he do? He goes 30 minutes at a speed of 450. So half an hour. So this is 225 miles. He's gone 225 miles. He's going 30 minutes, which is half an hour, at 450 miles an hour. Now he changes course. I'm going to get a different color. He changes course. So I'm going to put another compass right here. And now and by the way, I'm going to go ahead and do some marking here. We got parallel lines all over cut by a transversal. So if that's 40, this is 40. And if that's 50, this is 50. I may need that in a little bit, so I'm just going to go ahead and mark it now before I get my next line drawn in here, which is now a course of 230 degrees. Now, 230 degrees, remember, this starts here. This would be 180, so 230 is going to be here like this. Now that's 180, so isn't this going to be 50? This is 230 degrees. So from here to here is 180, and then I need to go 50 more to get 230. Now I'm glad I wrote that in there because now I can see I have a right angle. And how long did he go that way? Another hour. So this is actually going to be now 450. And I want to know the bearing and the distance at that point. So I'll use yet another color here. I'll put my blue in from the airport. So remember, this was the airport. Oop, I kind of missed. There we go. All right. This, guys, is the hypotenuse of a right triangle. Right? There's your right angle, 450 and 225. So we can find this distance quite easily. Let's go ahead and do the Pythagorean Theorem. So 450 squared plus 225 squared. And then let's square root that number. And his distance from the airport is 503.12 miles, approximately. Now, I really am running out of colors here. I really need to know this green angle. That's what I really need to know. I need to know that green angle because that would be his bearing. That would be his direction. I think I can find this red angle pretty easily. This is a right triangle. Let me call this X. Can I say something like tan X equals 450 over 225? Opposite over adjacent. This is the hypotenuse. So opposite over adjacent. So that big red angle, second tangent, 450 divided by 225, 63.43. Now that's not my answer, that's the big red one. You can do this a couple different ways. Remember, this original angle, the black angle, was 320, right? So the black angle is 320. The red angle is 63.43. So if I subtract those, will that give me the green one? Yes, it will. So let's take 320 minus that angle. And 256.57 is our bearing. 256.57 degrees. Now, we could also have, we knew this whole thing is 63.43, but we know that part's 50. So we could have found this little part right here, which would be 1343. And we could take 270 minus 1343, and that would have given us the very same angle. Wow, lots of problem solving there. Well, folks, this is a long video. It's been a long day. I hope I didn't make too many mistakes. If there's something that you're pretty darn sure I'm wrong on, you'll be in the Learning Commons with Mr. Leisure. You're talking with each other, so sort it out. I hope I didn't mess you up too badly. Have a great day.